12 noon. Good afternoon, everyone. Welcome to the Dorman Lunch and Learn. Sorry to get you nauseated. They got my picture in a couple of places. A new format here, but hey, we still give you great information. We're here for air fuel sensors, info, and testing. Okay. There's a disclaimer thing. There's junk about me. We don't care about that. Here's what we're going to speak about. Air fuel voltage levels, air fuel voltage level terms, air fuel data, and case studies. We'll be here for roughly about an hour, maybe a little longer. It all depends. Any questions you have, type them in the chat, and I will address those questions as they come up. Okay? So here we go. So air fuel sensors, how many of you realize that these are all different numbers for every different vehicle? Unlike an oxygen sensor that we would all agree most of the time is 0 to 1 volt, right? Now you got to be careful. If you're on chassis ground on a lot of oxygen sensors, I want to bring this up, you will read 2.5 to 3.5 volts, still a 1 volt range on Stellantis products. So you got to make sure you back probe not into just the signal wire, but the ground wire for that oxygen sensor. And if you go into many new GMs, rather than 0 to 1 volt, you'll be 0 to about 780 or 800 millivolts, 1 volt, 800 millivolt range. So what you need to do is just go into the sensor ground wire for the oxygen sensor, not the heater wire, because that's the regular ground. And that being said, for example, vehicles that use air fuel sensors have this before the catalytic converter and a regular O2 after the catalytic converter. O2 switch in voltage from rich to lean, while air fuel stay to a close, steady voltage. Note, some newer vehicles now not only use the air fuel sensor up front, but now use them in the rear. And keep your eyes open for them, because that's going to be the way everyone's going to go. Remember this, excuse me, even on a regular air oxygen sensor in the rear of the CAT, that could trim the fuel trim. Don't think it's only from the front air fuel sensor. The rear oxygen sensor can do that, and so can an air fuel ratio sensor. So please keep that in mind. Sorry about that, got a little bug in my throat there. That steady voltage differs by vehicle manufacturer, like I just said. Plus, it can only be measured accurately in most cases with the scan tool and enhanced OBD2 mode, or by the factory software, as well as with the meter. Because many foreign vehicles use the AF sensor, be aware that many aftermarket scan tools may not read or display the reading properly in generic OBD2. This is very true, especially if you haven't updated your scan tool. Make sure you get updates. Don't be behind 2-3 years. You can really lose a lot of data. Now, normal range here on a Toyota. Toyota is the only one that publishes this type of information. They tell you they got a range from 2.8 to 3.8 is where they like to stay. But this number here, I want you to circle that number, 3.3 volts. That is on a good running Toyota engine at idle, will give you perfect stoichiometry of the air fuel ratio, 14.7 to 1. Remember, the sensor does not bracket the mixture with high and low voltage. It doesn't toggle it. It measures the mixture exactly. So the voltage does not dither, meaning it doesn't do this. Doesn't go up and down like a regular oxygen sensor does. It is two zirconia sensors inside of each other, but it's a steady state. And we'll show you an example later. If you're trying to do a P0420 or 430, you definitely want to graph stuff, right? And if you graph it, you would think here's your regular oxygen sensor up front doing this, right? Air fuel is just going to be a straight line, and it ain't going to move much. It's going to move just a itsy bit. Okay, so keep your eyes on that. Now, air fuel wide range, same thing. Generic global may not display the true voltage. Especially, I want you to write down here, especially if you haven't updated your scan tool. Snap-on made mistakes on this. eScan made mistakes on this. Auto Ingenuity, you name the company, they made mistakes in the beginning because companies were saying it was a oxygen sensor, and it wasn't. It's an air, fuel, or wide range sensor. So rather than reading a scale from 0 to 1 volt, they needed to read a different voltage scale, because these things can go up to 5 type volts. 3.3 normal on a Toyota, right? So what you're seeing is a percentage of it. If your scan tool hasn't been updated, rather than reading the 3.3 volts, your scan tool is going to tell you you're reading roughly about 680 millivolts. So please write that down. About 680 millivolts. This would be in generic mode. If that happens, always go in to enhanced mode, meaning go into Toyota or Nissan or whoever. And remember what I said here in the beginning, just the slide before this one. Not all car companies use the same number. You go, what do you mean don't use the same number? Yeah, if you're on a Nissan, it's not going to be 3.3 volts, it'll be 1.4 volts. If you're on a Hyundai Kia, it's not going to be 3.3 volts, it's going to be 1.9 volts. If you're on a Nissan at 1.4, 2007 and down, and 2008 and up, 2.2 volts. And if you're on a Honda, it's 2.8 volts. And if you're on a lot of domestic cars, like a Ford Motor Company vehicle, or a Euro car, you're going to look a lambda of 1. So hopefully you got that and you write it down, okay? Here is the eScan from years ago. They've been reading the correct readings for a long time, but let's take a look here. You see what it says? O2 sensor, bank 2, sensor 1, 650 millivolts. Bank 2, O2, excuse me, bank 1, sensor 1, 645 millivolts. That's because they weren't given the right information. All these scan tool companies buy the information off ETI. ETI is Equipment Tool Institute. Just like you pay for All Data or Pro Demand or Identifix, Motologic, we pay money for that, right? And the reason why we pay money, they have to pay money to Toyota or GM or Honda or Mercedes or BMW or, you know, any of these companies, Toyota. This is the same thing with ETI. They paid for it, but the information wasn't out there right away. If that makes sense to you. Okay. So terms to know. I think we got 40, okay. So here's the oxygen sensor that goes up and down, right? That's what we're normally used to. But here's an air-fuel ratio sensor. It's just a straight line of voltage. And if we look at something like this, this is important. I want to blow this up. So let's say you're working on a car, a Bentley comes in your shop. Lucky you, right? Or a Ferrari or a Lamborghini. I don't have any of those factory scan tools. But if I want to know if that vehicle is in fuel control, I could go to their fuel injector, and this is the fuel injector right here, right? From here to here is called pulse width, okay? This is the ground that the computer's supplying. This is system voltage here. So you want to check your alternator. You want to check the charging voltage of the vehicle. You see we're at 10 volts per division. Each dot is 10 volts. I can tell you, well, this is on the other dot, we're about 14 volts or so, because you can see the difference from down here. This would be 10 volts. We're probably at 14, 15 volts right there. So we can see if the alternator is working. The next thing you want to know is, I have a question for you. What is the proper on time of a fuel injector on a hot motor, non-GDI first? So a regular injector, non-GDI injector, ported injector, you know, the regular injector system. How much on time do we have at a hot idle? Type it in. How much on time do we have? Okay, I see someone put 2 milliseconds in. All right, anyone else? We got 3 milliseconds. All right. Come on, guys. Type it in. Thank you guys for doing that, by the way. 1.2. Okay. So I'm going to want you to write down what I'm going to tell you. 2. I see 0.8. Okay. Here's what you're going to normally see. Just like this injector here. Notice this is 2 milliseconds per division. This is 2 milliseconds. That's 4. This would be 6. You're roughly about 4.5 milliseconds. So I want you to write down from about 3 to 5 milliseconds is normal injector on time on a hot running engine. This is non-GDI. Now take a guess at GDI. So gasoline direct injection. First of all, what do you know about it? Oh, gee, it has higher pressure. That's right. So now that I gave you that answer, in case you didn't know that, what do you think the injector on time is going to be? Is it going to be higher or lower? Type that in, please. Let's see. I'm waiting for some answers to pop in here. Okay, 0.8 to 1 milliseconds, lower, lower, lower. Good, good. So the 0.8, I'm not going to disagree with. You'll be somewhere 0.5, 0.8 to about 1 to 2 milliseconds at the most. Okay, that's where the injector is going to be on opening time. Now, that we know that, if this is our air-fuel ratio sensor, and it's not going to go far, the line's either going to go straight up or straight down. So, if this line right here, and Doreen, come right onto the screen. If this line here is going up, first thing we need to know. So here's the line, but if the line goes up, is that a rich condition or a lean condition? So I want you to type in R or L, because this is very important. This is super important for you to understand. So R or L. So I see there some R's. I see another R. R, 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 R. Ah, someone there. Jim. Yep. With an L. Okay. You could stop writing in. I want you to write this down. When voltage goes up, this is the opposite of an oxygen sensor. Okay, everyone understand what I'm saying? Opposite of an oxygen sensor. High voltage is a lean condition. High voltage is a lean condition, and low voltage is a rich condition. It's just opposite of what we know about the oxygen sensor. So that makes sense to everyone, okay? Now, you know that you just found out, and some of you were right, this is a lean condition. If this is lean, what happens to this fuel injector? Does the fuel injector come out, or does the fuel injector go in? So more on time, you could type M for more, or L for less. M for more, L for less. Okay, you guys that put more in, absolutely correct, because a lean condition is going to be a command to the computer. Hey, I need more fuel. Give me more fuel, a rich condition. So the injector would come out. Is everyone good with that? Give me a G for if you're good with that. Okay, excellent. Thank you for working with me. I appreciate that. Now, the PCM constantly adjusts the fuel delivery commands up and down, trying to bring the engine as close to a perfect air-fuel mixture as possible. O2 or air-fuel sensors could have a profound effect on fuel trim, and they do. They do have that profound effect. If they're not reading correctly, you put the wrong one in, or you got a defective sensor, you got a problem, because you're not going to get the right fuel delivery. Very important to know that. The wrong voltage reading from either sensor can cause fuel trims to go off course and cause a drivability problem or a DTC. Remember, don't be totally code dependent all the time. People always want to look at a code. Sometimes there's not a damn code, right? The thing ain't running right. Customer may complain, hey, my mileage is down. excuse me, their mileage is down. Did you look at their fuel trim? And by the way, what are good fuel trim numbers at idle? A good hot fuel trim number, type in what you would say is acceptable. Well, I take a sip of my water. Okay, so I see some here, plus or minus 10, plus or minus 5, 4 to 8, 6. Okay, you guys are in the ballpark. I personally like a plus or minus 6, okay, but a lot of this tool manufacturers do tell you plus or minus 10. Problem is, a plus or minus 10, if you're at 10, you got a problem going on, a real bad problem. I like to look at that plus or minus 6, then take into account what's my grams of air on the mass air, or what's my load sensor, the speed density map sensor at, right? Where's my other readings? Where's my idle at? Am I near desired idle, right? Where's my timing at? So I like that 5 to 6. 6 is usually what I use, okay? Now you can do what you want, what works for you, but 6 is a good number to start investigating. Okay. Now basic terms, short-term correction, long-term correction, total fuel trim correction, and lambda. Okay, so let's talk about short-term. Short-term means short-term fuel trim is happening right now. If I'm here, long and short-term right in the middle, okay, if short-term starts going like this and it gets to its limit, it bounces back, and now the long-term back here is going to move one up, right? And then it gets to a certain point where you're going to get a P02 code, okay? That is for fuel issues. So that is short and long-term, how they work with each other. If short goes out too far, hits its limit, long-term clicks up one, or could go negative, right? If you're taking fuel away in short term, because maybe you got high pressure fuel problem, you got a pressure regulator, leaky injectors, stuff like that, it's going to start deducting fuel. Short term gets to its limit, and then long term will take over. Total fuel trim. I want you to write this down. Total fuel trim is short and long together. That's what total trim is. Long and short together. And lambda, super important. Remember I mentioned that before? Lambda is one of the readings for this stuff. Lambda, what is a good lambda number? Let's see. Type that in. What is a good lambda number? Good lambda number. Good, good, good. You guys are on it. A lambda of 1. Now, of course, it's best if you use a gas analyzer. We did a lunch and learn a while back with a gas analyzer. Maybe revisit that sometime in the future. But a lambda 1, you can even see on your scan tool. They're using that as scan data now based off the air-fuel ratio sensor or the oxygen sensor on what that vehicle's doing. And that will look at fuel trim and total trims. Short term occurs as a direct result of change in the oxygen content in the exhaust stream. Remember, 19 to 21% oxygen in the air we breathe. How much is left over is important. The suck, squeeze, bang, blow, so you get intake, compression, power, exhaust. You're not going to use all that 19 to 21% up, okay? So some has to stay over, and our catalytic converters nowadays are called what? Oxidizing cats. No air pump going down to them. 1996 here in the US, 1998 in Canada. That's when OBD2 started there, and 96 here for us. So no air tubes. The substrate of the catalytic converter has to be able to take that couple of % of oxygen left over from the intake, compression, power, exhaust, and basically use it. It'd be like a fire smothering. When you put oxygen to it, it reignites and helps burn everything up, okay? That's why catalytic converter temperature will be hotter at the outlet than the inlet. People always think it's to be hotter coming out of the motor. No, the chemical reaction will make it hotter as it's leaving the converter, okay? So oxygen sensor signals voltage generate is directly proportional to the oxygen content in the exhaust. And this is the same for air fuel. The correction made is immediate one. It adds or subtracts fuel. Long-term, learn response based on the activity of short-term. Once enough fuel has been added or deleted to correct the condition, long-term will adjust itself based on short-term fuel trim values. The goal is to get short-term to go back as close as possible to zero. Now, that being said, not everything is going to be perfect. You're not going to be at zero. You're going to see, that's why I like using 6. You're going to see a lot of cars, 2, 3, maybe 4, don't have a baby over it. It's going to be running quite well, okay? Look at all the other factors. In other words, look at your close to desired idle. Look at the timing, right? Look at your load sensor. Make sure all these things are good, and don't forget baro. So here we're 40 miles north of the World Trade Center. We're roughly 300 feet above sea level, okay? So Manhattan's down at the water. We're a bit up over here. Now, knowing that, my baro pressure is 29. Not much of a big difference than being down there. It's probably some 1/10 of a point or so difference. Do you know what your baro is where you're at? Why do I say, do you know what your baro is? Baro controls fuel and controls spark. So if we have wrong baro readings, you could be chasing your tail going through the wrong info. Always look at baro as well. So when we go in, not only DTCs, but we want to look at the PIDs. Are we near the desired idle? What's fuel trim doing? What's the air fuel ratio sensor doing? What's the rear oxygen sensor doing? We're going to talk more about that in a bit. And look at baro. Is it good or bad? Okay. Total trim correction, short-term and long together. And then EFT, short and long-term and rear fuel trim correction. And then acceptable range. There's the range. Here's where you should be this and under. Again, I use 6, but these are what scan tool manufacturers kind of look at. And remember, they're always going to give you some leadway because they don't want their product looking bad, right? They don't want that looking bad. Lambda, the ideal value, we went over this before, is 1. The value is greater than 1. The system is running lean. So once again, it's the opposite, running lean. If the value is less than 1, the system is running rich. So lambda is a very important thing to look at again on your scan tool. Are you running lean or rich? It'll give you that information. Okay, here's a little test for you per se. Basic terms and review, short term, if it's 0.36, varying and positive, so it's going 3.6 and up. Long term is a negative 18, okay? Well, the correction for this condition would be what? So if you had these readings right here, what would the correction for this condition be? Okay, seeing numbers. Okay. Yeah, you guys want to put rich or lean in. Thank you for the numbers. So we got a lean, we got a rich, we got a rich, we got a rich. Yeah, it would be a rich condition, okay? So correction, if we're taking fuel away, right? You got negative numbers. The correction for it would be a rich condition. You have a problem there with something dumping extra fuel. If the PCM correction is correct, what would the value we notice on lambda or on our 5-gas? So if the computer is giving us the right correction here, where would that lambda number be? Where would that lambda number be? Would it be above 1, under 1? Remember how it works, right? Okay, I see a lot of less than 1s. So if the PCM correction is correct, remember, negative Less than 1 would be correct. Excellent. Thank you so much. Okay, now, you know, your readings, whether on a oxygen sensor or air fuel, are not going to be correct if the exhaust system integrity is not together. So, on some Nissans, look for cracked manifolds. Pipes. On some of the Hondas, flange gaskets, okay? A lot of times they're not bad. I mean, they're not good, they're bad, and that could even cause a P0420. So look at the exhaust system. How do you check the exhaust system? Well, if you have a high pressure smoke machine, not one for evap, but one if you're working on diesels and to check, you know, all the boots and connections, you're going to have a high pressure diesel type of smoke machine. Most of you probably don't have that, but you can do this simple setup that we made here in the shop. You take your exhaust cone that came with your smoke machine for evap. Remember, that's only 1 psi of pressure. And what you're going to do is put a pressure gauge on it. And we're going to tell you, you don't want to go over 5 psi. So write that down. You don't want to go over 5 psi. The other thing, when we do any tire repair or tire checking, we use a company called Tech, T-E-C-H. It's a red and black type cabinet. They got all the tire patches and all the other fancy cleaner stuff. What they make is amazing. They make this purple type of soapy bubble type stuff that is way better than any dishwashing detergent or other bubbly stuff that you can use. And when we spray that, it really enhances the bubbles coming out of any type of leak. Not only on air leaking out of a tire, but we're going to show you right here on the exhaust. So take a look at this.
All right, we got a 2008 Jeep Grand Cherokee, 3.7 liter, and it's got a P013C for downstream bank 2 O2 sensor slow response. The dealer already put new sensors in, so I made this rig up to apply about 5 psi of pressure, no more than that is the spec to check for leaks. And I found this joint here, sprayed some soapy water and found the joint leaking. It's this O2 back here, the rear bank 2 O2 that has the code. A lot of times the welds around the exhaust fail and that's the cause of it. The dealer already placed a sensor on it. So we're just checking for leaks, and I'm going to fix this leak before we go too much further with the diagnosis.
So you can see that those bubbles come up, went to the dealer, had a problem. If you have dual exhaust, obviously block one side and put no more than 5 pounds of air pressure. Now, your shop vac, I see a couple of people put that down there. It works pretty decent, but you don't know the flow rate actually coming out of it. When you can put 5 pounds of air pressure and actually measure it. But if that works for you, you continue to do it, okay? If you use an older smoke machine that's just made for evap, it's going to take you a long time to get that smoke through the system to find the leaks. If you have a high pressure one, not a problem. It's going to kick ass. You're going to find that leak pretty quick. Okay, scan tool data. Now, when we look at this, this is a 2007 Nissan. What did I say before is the right reading for a good idle reading for Nissan? Remember Toyota was 3.3? Where is 2007 and down Nissan numbers? Where is the air fuel ratio number on a 2007 and down when they first started using air fuel ratio 7s? Okay, look at that. Excellent memories. 1.4. Let's take a peek where we're at over here. Air fuel ratio sensor, bank 1 voltage. We're at 2.17. On both banks, we're high, 2.2. Is this an indication we're running rich or lean? So I want to see an R or L in there, an R or L. Okay. Okay, I see 1 R, 2 L's. Okay, let's take a breather here. If you didn't put L and you put rich, you're forgetting when the number is higher, Write this down if you got it wrong. Don't be embarrassed. Write it down that when the number is higher than the 1.4 in this case, you're running lean. When it's lower, you're running rich. It's just the opposite, and put in big letters, opposite of O2. Not a hard thing to remember. And you can see, look, if you look at more data, it tells you it's running lean, okay? So this is a snap-on screenshot. Let's take a look here from a Ford. Here is a 2196, and let's talk about the 2195, 96, 97, 98 that they use on Fords. When you see those numbers, they're using an air-fuel ratio sensor up front, okay? And Ford's been doing this for quite a few years. They did not do like a 171 or a 174, or 172, 175. They didn't give you, here's how that code sets. For some reason, they left the code numbers there, but they don't give you a good explanation, okay? So when you look at that, it says O2 sensor signal stuck rich, bank 1, sensor 1. So it's stuck rich. Now, when you go down this chart of freeze frame and you see something here, you see our lambda? Look where our lambda is, 0.66. So lambda, what is that really telling you? Lower number, I want to see a L or an R. So what's that number telling us right there? You got 0.662. Good. You guys that got R, you're getting it. Excellent. Excellent. Okay, because a lean condition is going to make a rich command, right? Excuse me. Look at our O2 sensor 1, okay, sensor 1 in milliamps. You see that negative number there, -2? Well, that is telling you that the negative number, when you do amperage on air-fuel ratio sensors, 0 is about perfect. Anything that's negative, okay, is basically a rich type of condition, it's saying. Anything that is positive is a lean condition. So you back up your findings by using that data. And by the way, don't forget, if you have permanent DTCs, would you have it in 2015? Let's say someone erased this code. Would you come up with this code in a 2015 vehicle? Give me a Y or an N. See, today I'm in a questioning mood, okay? So sorry about that, but I'm in a questioning mood. So Y or an N, okay. So we see Y, yes. I want you to write down 2010 and up vehicles. Permanent DTCs is what mode? What's the name of that mode? Type it in. What's the name of that mode? Okay, we see a guy has it there. Yep, mode 10, excellent, excellent. You guys are on the ball. 0A10, the engineers like calling it 0A/10, so mode 10 or 0A or both of them. Excellent. Now here's Toyota wide range. And what do we know here? What is going to be the perfect reading on a Toyota? What did we say? Good running Toyota? Good, 3.3, look at that. Okay, so here we go. Bank 1, sensor 1, air fuel voltage. We got a lambda, a 1. We have the air fuel ratio, 3.3. Bank 2, we have a lambda, a 1. And we're at 3.28. Pretty damn close. So you got an engine that is running pretty good right there. Does that make sense? You're not always going to be, 3.3 on the head. 3.284, come on. It's right near 3.3, right? When you're off, maybe you're at 3.1, you're at 2.9, you got something to be concerned with. All right, let's take a look at mode 6 data. Now, mode 6 data here, and, sorry you got to see a lot of eScan, but this is the easiest thing, in my opinion, to use, because first of all, there's only 2 scan tools on the market that read mode 6. You see I have it highlighted continuously? So what that means is rather than going like this and reading mode 6 once, this is going, give me the latest update. Give me that latest update. Now, you got to drive it down the road, but this is going looking for it. The other one's going to do this. You'd have to back out of mode 6, get to the beginning part of the scan tool where you're going in to, in this case, Toyota, and flip back and forth to try to get an update. So Auto Ingenuity and eScan are the only 2 that read continuous. In my opinion, that is a big help. When we've done some webinars with Motor Age and TST in the bay, we've had some cars update right in the bay. It's not normal. Normally they need to drive, but certain functions like misfire, and a couple other things may update. And it did right on live video, okay? So here we have an air fuel response rate of test value 0.909, minimum of 0, and a max of 5.9. So we're well in the range right there. Bank 1, Sensor 1, air fuel current. The current, my eyeballs are pretty bad, but I think it says 4.0, minimum 1.4, max 3.5 milliamps. So it does not like the current reading. And remember, when you're reading a high number, what does that mean in current? Remember, we said we looked at the negative number. What's that high number mean? Someone has something there about IDS does not update continuous. No, it doesn't. IDS does not update continuously. I love it for whatchamacallit. Okay, so excellent. Excellent. So the higher number is going to be lean. Good move, guys. Now look at this. Here's where you can get into some poo-poo. Now, it's not a very common tool, but this is the Hyundai, Kia, and Genesis tool. They're all separate, by the way. You can't buy one tool to work on all 3 of them. You need 3 different damn subscriptions, which is a crock of bull, but that's the way it is, okay? They make a mistake, number 1, call in their air fuel ratio sensor in O2. This is the factory tool, okay? Now, Hyundai, Kia, a factory tool was not configured properly either. Take a look at the O2 sensor voltage, and you'll notice it states O2 with a voltage range of 2 volts. The normal reading is 1.9 volts for their air fuel ratio sensor. So when you look at this, you'll see they got a scale up to 5, and you could see here the reading you're getting in the middle is the steady state. You'll see when the RPM was low, this was down, a rich mixture as we're coming up, okay? And when you step on the throttle, you see how the RPM went up? What happened right there? We went down. We went lower. Lean, or low, I should say, is not lean, it's a command for rich, right? Now look, here I go brum, brum, brum with the pedal. Here's the air fuel ratio. Again, they're calling it O2. You would all say these are all humping up. What's going on with the engine speed? Humping up. What's going on with the throttle position? Every time I hit it, where does it go? Low. Every time I hit it, where does it go? Low. The RPM goes up, but look at that, okay? That proves that when you're doing a command for fuel, APP, and of course they call it TP, wasn't a throttle position sensor, it was an APP sensor. So even OE scan tools can name things wrong. There's a big difference between an oxygen sensor and an air fuel sensor, okay? Totally different type of makeup. And here, as the throttle position and engine speed goes up, the mixture gets richer, the voltage declines. Voltage goes up when the engine speed and throttle position decline, as the mixture is leaned out to bring the car back to proper air-fuel mixtures. Don't get confused by scan tool PIDs. The graph above can be confusing if you're not aware. Hyundai, Kia, and you write Genesis in there, has air-fuel as the O2 sensor. Okay, let's take a look now. You want to check for a P0, 420, or 430, right? Sure. You could graph it. You don't need eScan to do this. Just take any graph and scan tool and take the front and the rear. This one has one rear O2 sensor, the red line right here. And if you look at it, rear O2. This is the front air fuel and the rear, the bank 2 air fuel. This is the rear O2 voltage. What you want to make sure of is that both of these lines are nice and steady. You want to make sure the rear O2 is also steady. If the rear O2 is doing this, if it's bouncing around, you don't want that. That's telling you you got a cat code that's going to come up. You want to test that at 3 different speeds. Again, you can do it on a Snap-on, an Autel, a Launch, Top-Down, whatever tool you want, okay? The O2 fix thing that I did a while back. The, what was that, Think Car one we did it on. I don't care what tool you have, you can do it, and you need to do it, and confirm, do I have a rear O2 controlling my fuel trim? Your air fuel is totally perfect up front, but the rear, if it's not dithering like this, maybe it's not moving. So if you see a rear O2, I want you to do this every time. First, check it at idle. I want you to bring the speed up to 18 to 2,000 RPMs. Then I want you to bring it 28 to 3,000 RPMs. And if the readings stay good, like this, we would want 80%. But if the rear is not dithering up and down, okay, you're good. But you need to do, and it's not Mr. Ed saying hello, right? That brum, 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 you want to see the rear O2 do what? And this is important. What do we want to see the rear O2 do? Type it in there. What do we want to see it do?
Jump, spike,
Spike, good. Go up and down. If it ain't going up and down, that rear O2 is going to be controlling your fuel trim. So write that down. It's going to be controlling your fuel trim. Very common. A lot of people don't realize that the rear O2 sensor could control your fuel trim reading. And nowadays we said what? Some of the vehicles are now coming out, and they're already out on the market. Some Toyotas, Audi, Volkswagens, and other manufacturers are using a rear air fuel ratio sensor. Now those are not going to do that, but you should see some movement. In other words, maybe the line is here. You want to see that thing move a bit, right? It ain't going to dither. It may give you a little bit, but not a lot. Okay, very, very important. Any questions on that? Okay, let me take a sip here. We're going to look at the Scion. This is Toyota TechStream. And by the way, the old TechStream, in my opinion, was better than the new stuff out. I'm going to blow this up here. And this is the older version TechStream, just so you know. So we have air fuel bank 1 sensor 1. It's at 3.28, very close to 3.3. Short-term fuel trim, minus 0.4. Long-term fuel trim, 3.0. We're not going to have a baby. Look at our injector, 2.4, roughly 2 to 5 milliseconds, right? And our rear O2, O2 sensor, bank 1 sensor 2, 390 millivolts. Now, you can see we're graphing it. I have bi-directional control on. One of the nice things with this tool, and by the way, there's a lot of your scan tools out there that do a terrible job when you're trying to do bi-directional. Yeah, you can pull it up, but all of a sudden the PIDs you want to look at, they're not there. You need to write it down and contact that particular scan tool manufacturer. Now, I know this because I've beta tested a lot of different scan tools, and I've told some of them, hey, the information that I want to look at is not even available on that stupid screen. What good is me doing that if I can't look at, is there a change? So watch what I'm talking about here. You could see that the air-fuel ratio here, I'm having it go up and down. Now, there's not a huge difference, 165, 177, 181. But you could see it when it's graphing out, right? So here I am commanding 25%, okay, a plus 25%. So the air-fuel bank 1 sensor, and look what happened to the voltage, 1.77. Remember, lower is what? Rich, right? So we know the system's working. Then we got short-term fuel trim is taking it away, and look at long-term. Look at our injector, went up to 3 milliseconds, okay? And if we go down here, what happened to the rear O2? It's showing us we're rich, lack of oxygen, 0.875. So it proves to us that rich added fuel, you could prove if your system is in fuel control. That's super important. Are you in fuel control or not? Now look at the review here we have. You have air fuel voltage, short-term, long-term injector, and air fuel lambda, right? Okay, normal 3.3, a negative 0.04, you've seen that. You've seen here the 3.09 long-term adjustment, injector 2.4, and a perfect lambda of 1. When you were rich, 1.77, a negative 0.04, a negative 1.60, 3 milliseconds of on time, and 0.82. So it proves to you the lambda is showing us the rich condition, air fuel is showing us that, and now if you go lean, the voltage goes up 3.80 on the air fuel. Not much change here on the short term, exactly the same as rich, 2.8 and 1.14. And notice here, I went with a negative 12.5. That's the reading. And look at the readings here. So when you have bidirectional, you want to prove something out. Am I in fuel control, or the computer, we should say? If the PCM is doing its job, everything I just showed you here on any vehicle, any engine, should be proving that out, okay? And then you'll know if you got a problem somewhere. If you can't prove it out, must be something wrong. You know, I just had a student of mine call me early this morning, and he said, oh, you know, I can't get this car monitors to run, and the Subaru's giving me a hard time. I said, dude, you got to check everything from the battery. Is it the right battery in the car? Okay. Is the alternator working correctly? Do you have the correct antifreeze coolant in there? The right thermostat in there? All these things that you would go, oh, that don't really matter. Do matter. Because if a monitor's not ready, where do you think I told them to look first? Go into what? What do you think I told them to do? Besides looking at data that he says is not a problem, where would you tell them to go? Besides go somewhere else, right? OBD2, yep, good, but what part of OBD2, to be specific? Good. Mode 6, good. Mode 6. Excellent, guys. You guys are doing good. Air fuel sensor design. Now, there are different designs. Here are 4 and 5 wire sensors. Ford did a 5-wire sensor. And look, they've been using it from '97. Subaru, 4-wire. Toyota, 4-wire. Honda, 4-wire. And Nissan, 5-wire. All 4-wire sensors are Denso. All 5 wires will be Bosch or MTK. Write an important note here on slide 34. Very, very important. Whatever you take out that's OE, make sure you put in. Don't go with your favorite company. Go what came out. These things are specific. And sometimes you're going to need to pull your ohm meter out. Yeah, I'm not a big ohm meter guy, but if you have different heater resistance, you could have a different problem. It could be a different sensor. And remember, God gave us important tools: your brain, your eyes, your ears, your nose, your hands. Take a careful look at the sensor you're taking out. Is the one you're putting in look similar? If it looks totally different, don't put it in. Go back there. 5 wires, and you may see 6 or 7 going out of the vehicle. So 6 or 7 wires sometimes come out of the vehicle, but they go to a 5-wire sensor. Let's look at a Honda case study here. Okay. Got to make this quick. Here's the 2000 Honda EX. Miller's on, got a DTC 1167. The shop changed the air fuel, came back with it on, and you go look up, courtesy of Honda Motor here, but this is where you need to RTFI. Read the frickin' information. It tells you here the heater element ratio, but look at this. The sensor cell resistance is 80 ohms or more for at least 60 seconds. It's going to put that damn code on. Okay? It's going to put the code on. You know, before you run to that shiny toolbox of yours, make sure you look at service information. You know, remember I said the brain, the eyes, the ears, the nose, the hands? We got to use them. Look at stuff. You may see the problem. You may hear the problem. You may smell the problem. You may feel the problem. But using your brain and your eyes, you could look in service information and find this bulletin on this. So now we back probe the connector, right? Want to make sure where you're at. We see here the original air fuel heater internal resistance is 2.8 ohms. This is how many amps it should pull. A new aftermarket sensor, okay, has internal resistance of 18.9 ohms. So this may be your favorite brand. It ain't going to work too swift. A new OEM air fuel ratio has internal resistance of 1.1 ohms. So the P1167 failed the test due to a minimal amperage draw. Now, why is that? Well, look, the higher the resistance, the lower the current flow is going to be, isn't it? So even though this thing looks similar, doesn't look exactly like that, looks similar to this, they have different resistant readings. Maybe they don't make that OE one anymore. You know, I don't know. But this is what the aftermarket sold, 18.9. This was from the dealer. Put it in. There's the new sensor put in the vehicle. And basically, it was fine. Okay? So the HO2S sensor 1 represents air fuel sensor current in milliamps. Positive current indicates a rich exhaust. Negative current indicates a lean exhaust. Air fuel represents short-term fuel trim. Air fuel average represents the long-term fuel trim. So that basically fixed that vehicle. Okay. Now we're coming to an end here. If you have any questions, you can type them in. Air fuel ratio sensors, there's so many of them out there. You know, you could buy a very expensive, they're about $1,000 or so, or maybe 700, I think my friend told me, $700-800 you can get one, but it is a very, very small amp clamp that you could read the current. Current is the most accurate, but I can tell you, why take out the backhoe when basically the shovel will do? What do I mean by that? Use your scan tool data. They usually don't lie on that, okay? So where is the voltage reading at? When you have all those numbers that I spit out earlier, you should be in good shape because only Toyota does the publishing of it, right? So let's see what we got there. Do you have a chart for the air fuel sensor voltages by application and year? I don't have a chart. I just know a lot of the stuff in my head by doing it. You may want to write down these numbers again. All right, if you're on a Honda, it's going to be 2.8 volts. This is on a good hot idle motor. If you're on a Hyundai, Kia, they're basically going to be 1.9 volts. If you're going to be on a Subaru, you're going to be 2.4 volts. If you're going to be on a Nissan 2007 and lower, you're going to be 1.4, 2008 and up, 2.2 volts. If you're going to be on a Toyota, 3.3. And if you're going to be on anything else, it's a lambda of 1. So there is the chart that's in my head from doing so many of these. Hopefully you wrote that down, and that'd be helpful. We want to give my buddy Swede, who will be on next Wednesday, the 26th, the Heavy Duty Lunch and Learn, HD suspension, A to Z. He'll cover suspension systems, all the components, case studies, and don't forget, there's not only spring type, but there's air type with heavy duty. There's some stuff there. We also have some stuff coming up. If you're down in the PA area, you'll see Josh Weaver. He's doing this at MAX, the Mobile Air Climate Society in Lansdale, PA. This is a hands-on lab scope class that he's doing. It is a one-night class. Check that out. If you're interested in a meter class, and that is February 18th, Tuesday. Here I'm doing a meter class. So if you stink using your meter, you want some voltage drop type of stuff, well, then you could have a problem if you don't come, because you won't be learning. And we'll talk about, I'll get to your question in a second. Last thing here, live webinar on Pete Meyer. If you're down in the Florida area, he's doing one here on voltage drop testing as well. We do in-shop training. We want to thank you guys for coming out. I'm going to take a peek at your questions. Doreen, does that camera have power? Because it's blinking.
I see it.
Is it plugged in or is there power out?
I bet you it's not plugged in. Yeah, well, you're
We
almost
just,
finished.
we're almost done. Anyway, let me see what your question is. How does a clogged cat affect an intake air temperature? Well, the temperature is going to go up. I think the camera went out. No, it's still on.
Yeah, it's still on.
Whatever you did, I guess you
on.
fixed it. Okay. Sorry about that. Do you think this stuff was helpful? If it's helpful, give me a letter Y. If you don't think it was good and I suck, give me the letter S. So Y if it was good, S if it sucked. We do have surveys here. You can go to the webinar survey for us, helps us out. There's our Facebook group, and we do have a newsletter that you could click at the end of your
Want to
thing.
know where the in-shop training is located?
Okay, so in-shop training is at your shop. If you're interested, you got to email me, and that would be back here. Email me at gtruglia@dormanproducts.com. And we will, in fact, I'm going out to Indiana next week to do an in-shop training. Josh will be down in Georgia doing one. We have a minimal of 2 days. You can get up to 12 people together in your class. We'll give you pricing. You do need seating for people, tables. You know, you supply the food, we come out, we supply all the training, including the hands on the vehicle. But we need a picture of your facility. You got to sign some paperwork, because obviously we don't know your shop. So thanks. Can you put the readings in a chart? Can you repeat one more time the number of values? Sure. Okay. So Honda is 2.8. Hyundai and Kia is 1.9. Nissan before 2007 is going to be 1.4. 2008 and up, 2.2. Subaru, 2.4. Whom are you forgetting? Toyota, 3.3. And a Lambda of 1.
Did you say Nissan?
I did Nissan, both of them. All right, so hey, until our next Lunch and Learn coming up in March, wow. We'll try to give you a better heads up. You know, I'm sorry I've been on the road and have a couple other issues going on, but we want to thank you for coming out. Go to the Dorman Training website, and that would be some of the information you get right there, and take a look at the stuff we have coming up around the country. We'll also be out in the Chicago area. Ken Zanders is out there. He just finished up an electrical class. I think he's doing a lab scope one coming up. We have e-scan class, e-scope class. When you do come to our scope class, we cover just about every scope. Last class I had here, we had guys with e-scope, picoscope, snap-on, of course, Autel, launch. So all the scopes that you bring into the class, we can utilize them and help you be more proficient with them.
Can
So
you tell
thanks
the
for coming up.
gentleman that keeps asking for the PDF that I've posted it several times?
Okay, if you can't get the PDF there, it was in the original email as well. Doreen has posted it there. If you can't grab it in the chat and download it, then you'd have a problem. Okay. Yeah, 1.4, 2.2. Yep.
One more time.
Yeah, Doreen just reposted it there. So I want to thank you again from New York. I'm G. Truglia. Thanks for coming out. Have a great day. And, oh yeah, don't forget Valentine's Day coming up, a few days away. You know, the significant other won't be happy. So give someone a kiss, give someone a hug. Have a good one. Take care.